Welcome to my channel. So in this video, we are going to solve the very interesting problem. Already this problem is solved using Fourier transform also. Okay, so now we are going to solve this problem using Laplace transform. So it is a very repeated question. So it is asked 13 marks for the year December 2018. Okay, so sometimes instead of this A, there may be B given, or some constant 2 1 it may be given. Okay, so anyway the procedure is same. Okay, so here what is the given question means, find the Laplace transform of the signal x of t equal to e power minus a modulus t, okay, for a greater than 0 and associated ROC. So it is a what is the given signal? This e power minus a modulus t means it is a double-sided exponential signal. Okay, so already we solved e power minus at u of t signal, e power plus at u of t signal, e power at u of minus t signal also. Okay, but this signal is a combination of one causal signal and one anti-causal signal. So first we have to express this x of t in a expanded form. So how to represent this signal in a expanded form means, so e power minus a modulus t. So what does mean by modulus t means this t, if this t is having the positive value, this signal is working as some different signal. If the value of t is negative means at the time the signal it will work as a different signal. Okay, so first one we have to substitute in the place of t we have to substitute the positive value. So if the t is positive means, how to write this? E power minus at. Okay, which condition? During the time is positive. So this signal it will work as a exponentially, e power minus at means decaying signal. So it will work as a decaying signal whenever the time t is positive. Positive means t is 0 to infinity. So in order to indicate that t is positive, this e power minus at multiplied with u of t signal. Okay, and plus we have to, if the t is negative means, if the time t is negative means, so e power minus a minus t. So minus of minus plus, so it can be written as e power at. This is e power at is an exponentially rising signal. So in which condition it will work as exponentially rising? During the negative time. So in order to indicate the time minus infinity to 0, we have to multiply this signal with u of minus t. Okay, so the x of t, this e power minus a modulus t, it can be expanded as e power minus at u of t plus e power at u of minus t. Okay, or we can written as x of t equal to e power minus at for time t greater than or equal to 0, e power at when time t less than or equal to 0. Okay, so these are all the three types of representation of this signal, and the graphical representation for this double-sided exponential signal is, so the signal is an addition of two signal. What is the first signal? Exponentially decaying during the time t greater than or equal to 0. So the time t is from 0 to infinity. The signal is, what is the signal? It's exponentially decaying. So e power minus at u of t. Okay, so this half is a e power minus at u of t. And the next one, for t less than 0, it is a exponentially rising. So for t less than 0, what is the signal? The amplitude of the signal is exponentially increasing. So this is a e power at into u of minus t. So the addition of these two signal is said to be the e power minus a modulus t. Okay, so this is the thing. So what is our question means? Our question is to find the Laplace transform of this exponentially double-sided exponential signal. So first one, we have to write the formula for the Laplace transform. So the Laplace transform of any signal x of t equal to which is indicated as capital X of s, which is equal to integration minus infinity to infinity x of t e power minus st into dt. Okay, so now we have to substitute the x of t value. So what is x of t? The x of t, it is defined, it is having the different value during the different time. So the first one, the x of t is equal to e power minus at for the time t is greater than or equal to 0. Okay, so that's why in this integration is minus infinity to infinity. So this integration we are splitting into two integration. One is 0 to infinity, another one is minus infinity to 0. Okay, so during the positive time 0 to infinity, What is x of t? It's a e power minus at, exponentially decaying signal. Okay, for t greater than 0, it is a e power minus at. Into in the given formula, e power minus st is there, dt is there, plus for the time negative, that is minus infinity to 0. So for this negative region, okay, for this negative x-axis, for minus infinity to 0, what is the waveform? This waveform is a e power at. So e power at, e power minus st into dt. Okay, that's all. So this split up is important. Okay, so for the positive time axis, it will work as a exponentially decaying, e power minus at. For the negative time axis, it will work as a exponentially rising. Okay, that's all. Then in the next thing, in the integration, there are two e power terms there. So we have to combine the powers. Okay, in power, always we have to take minus t as a common. So we have to write e power minus as common. Here s is there, here a is there. So always we have to write s plus some value. Okay, s is a variable, Laplace variable. Laplace variable plus some constant or Laplace variable minus constant we have to write. Okay, then plus in this if you are combining e power minus of s minus a t. Okay, so we have to integrate this term. So if you are integrating this e power minus s plus a t, we will get e power minus s plus a t by minus of s plus a with the limit 0 to infinity. Similarly, if you are integrating this, we will get e power minus s minus a t by minus of s minus a with the limit minus infinity to 0. Okay, so if you are substituting the upper limit for this first term, we will get e power minus infinity 0. Okay, so minus of, if you are substituting the lower limit, e power 0 1 divided by minus of s plus a. Similarly, plus if you are substituting here, the upper limit is 0. Okay, when we are substituting the upper limit, we will get 1. When we are substituting this lower limit, we will get the answer as 0. Okay, so but here this minus of minus, it can be written as plus. So 1 divided by s plus a, and here here this minus is there, so minus 1 divided by s minus a. So this is the Laplace transform of the double-sided exponential signal. Okay, and the next one, if you want to reduce this term, means you take LCM. So if you are taking LCM, so here s plus a, s minus a, if you are multiplying s squared minus a squared, and here if you are taking LCM, s minus s cancel. So we will get the answer x of s equal to minus 2a by s squared minus a squared. Okay, so this is the Laplace transform of the double-sided exponential signal. Okay, double-sided exponential signal. And the next one, we have to find the ROC. In the question, they are asking find the associated ROC also. Okay, so when we want to find out the ROC, so the x of s, you see this one. Okay, so the x of s is having 1 by s plus a minus 1 by s minus a. But here, according to this first term, okay, according to this first term, so here there are two pole. What is the first pole? S equal to minus a. According to this one, the s is equal to plus a. Okay, there are two pole. So we have to mark the pole. So plus a means in the positive x-axis, you take this value as a, and another pole, it is a minus a. So in the negative x-axis, there are two pole, you mark as a cross symbol. Okay, and in order to find the ROC, so first we have to see the first term. So real of s plus a, that is we have to write real of this denominator term is greater than 0. So from this, the real of s greater than this plus a, it will come into the opposite side, means we will get minus a. So what is real of s? It's a sigma. So sigma greater than minus a. This is the ROC 1. Okay, ROC of the first signal. Similarly, the ROC of the second term is here minus. Okay, minus 1 by s minus a. Okay, minus 1 by s minus a. So if this minus, it will come, means already I told in the exponential anti-causal signal, we can write the real of this denominator part, it should be less than 0. Okay, real of s minus a less than 0. Why? Means this minus is there. Actually, real of minus of s minus a greater than 0. Then when you are multiplying throughout minus, means that a minus, if you are multiplying with greater than symbol, means it can be converted into less than. Okay, that's why. So from this, the real of s less than a. So the sigma less than a. Okay. So in the first ROC is sigma, the condition is greater than minus a. Here The second ROC is sigma less than A. Okay. So we have to combine these two ROC. Okay. So if you are combining these two conditions, we will write, you see, the sigma less than A but greater than minus A. So this is the combined ROC. Okay. So what does this means? So we have to draw the ROC diagram. So you see, this is a minus A, this is a plus A. So in the minus A, we have to draw one region. In plus A, you have to draw one boundary. Okay, so according to this ROC statement, the sigma value, it should be less than A but greater than minus A. Okay, so which region it should satisfy this condition? Sigma less than A. So less than A means this is the A. So A less than region, this one. Okay, greater than minus A, this part. Okay, so in which region the two ROC intersect is the center region. Okay, so this shaded region is said to be the combined ROC for the double-sided exponential signal. Okay, so you see, this is the ROC for double-sided exponential signal. That is the region between the sigma equal to minus A and the sigma equal to plus A. So this region is the ROC for this double-sided exponential signal. Okay. So, you know, if the given signal is a causal signal means the ROC is a right-sided portion. If the given signal is an anti-causal signal means ROC is a left-sided portion. But in the double-sided signal, okay, in the given problem e power minus a modulus t, this is causal, this is anti-causal. So the signal is a two-sided signal. So for two-sided signal, what about the ROC means? The ROC is a mid region between the two things. Okay, so the for the double-sided signal or two-sided signal, since this two-sided signal is having causal signal as well as anti-causal signal, for the entire time this signal is available. Okay, so for that signal, the property of ROC is that the ROC is the mid region between some poles. Okay, so this is said to be the ROC. Okay, so it's a very important question. So sometimes this question may ask using Fourier transform. If it is a Fourier transform means they tell draw the uptime the magnitude spectrum. If it is a Laplace transform means we have to find the Laplace transform and also we have to draw the ROC diagram. Okay, so in the mark split of itself, the calculation of Laplace transform, it produces 8 mark, and the remaining mark given for this ROC calculation as well as this ROC. Okay, so the ROC diagram is very important in the Laplace transform problems. Okay, so thanks for watching, and please subscribe my channel for more videos and keep watching. Thank you.